I demonstrated a developing capacity to make the mathematics curriculum accessible to all students, regardless of their personal characteristics, backgrounds, or abilities. To make my objectives more accessible to students with lower reading levels or my English language learners, I decided to have both a formal set of objectives and a simpler one that used pictures to represent more difficult terminology. So my objectives were, after math, you will say, I can write the addition and subtraction facts that make up a fact family. I know that fact families use 3 numbers and that they show how addition and subtraction work together. I made the concept of fact families more accessible to my students by using this authentic fact family activity. They got to split their families into girls versus boys or young versus old and see that the fact family rules apply to real life too, like a real family. And students from all backgrounds with all personal characteristics or abilities, they should be able to relate to this. I demonstrated a developing commitment to creating an inclusive mathematics learning environment that values learners and their ideas and supports individual and collaborative engagement in learning. I did this by using equity sticks to call students to answer questions or participate. At one point during my lesson, I called the blue table to come up and share what they had found during their fact family exploration. One of the students at the table has just recently come from the Dominican Republic and doesn't speak many words of English. When I called him up to stand at the front of the room with the rest of his team members, he was surprised and said, "Me? No." But I wanted him to realize that he is part of the classroom and to help him start feeling included in school, especially when students are getting opportunities to share ideas and collaborate. Too often he's left out of lessons because he doesn't have that letter sound recognition and doesn't know the vocabulary to participate in lessons. So I wanted to include him as much as possible.
So who was in the blue table? Jose and Samir. And Michael. Yeah? Yeah? Okay, so Michael, can you please stand up? Michael. Guys, I need you to sit quietly. Well, he is part of the class. Okay, and can someone sub in for Jose?
Here, students got to share ideas of examples of ways they could split up members of their fact families.
Down, take your jacket off your head. Alright, so let me hear some ideas. How are you guys going to be splitting up your family? Does anyone know yet?
Oh, I do.
Steven.
Boys versus girls.
So you're going to split your family into boys versus girls? Marina? Girls versus boys? Short hair and long hair? Okay. Boys versus girls. So does everyone know how they're going to be splitting up their families?
Yes. Tall and short.
Tall and short. I bet your parents are probably tall.
I demonstrated a developing capacity to build exploration into the learning experience that allows students to take charge of their learning and make sense of mathematics in their own way. I demonstrated a developing capacity to use relevant and meaningful context for connecting mathematics concepts and engaging learners in important cross-disciplinary skills, creativity and innovation, critical thinking and problem solving, and communication and collaboration. In order to create an inclusive mathematics learning environment, I created a student-centered exploration activity in which students got to choose how to split up their table based on characteristics like red shirts, white shirts, or boys versus girls, and they got to see an authentic context where fact families were used. They had to figure out what addition and subtraction facts belong in a fact family and communicate in order to figure those things out. And that really took care of my exploration objective as well and let the students take charge of their learning and make sense of mathematics in their own way.
Wait, 1, 2, 3. No, 1, 2, 3. Steven is where it was. Okay, now 2, 3. It's 5. Now we need to make something. 5 take away 2. Okay, oh no, 5 is 5. 5 take away 3. 2. 5 take away 3. 5 take away 3 is 2. No. This is already done. 5 take away 2 is 3. Okay, now this one. So it's 5 and 3 and 2 is 2. Okay.
I demonstrated a working knowledge of the central concepts and diverse ways of knowing and doing mathematics. Our textbook Elementary and Middle School Mathematics talks about how students can use several different methods to learn addition and subtraction. They can count on objects, use manipulatives, and then I also found some great ideas online. But here are some things that students can use to count: 10 frames and manipulatives. Just within the idea of fact families, there's so many different methods to teach this concept. You could start off with math blocks and show that 2 plus 4 equals 6 blocks. And then if you flip over that set of blocks, it's the same number in total, but you get a different describing addition fact. And then you could use that also for the subtraction facts. Then there's the crisscross method, where you write out the first addition fact and then you crisscross the numbers to show the next addition fact. And you can even have students jumping and crisscrossing their legs to remember this. And then just to remind them that the last digit is always the biggest in an addition fact, and then the biggest number is always the first in subtraction facts. And you can even draw a little square to help them visualize. And then another method that I found online was the fact family triangle. And then this just shows that the bottom squares, 2 and 4, add up to the top, 6. And then you can show them the different ways to read the fact family triangle. So these 3 numbers are always related, and this definitely helps them visualize that there's always 3 numbers in this fact family. And lastly, what I did in my activity was to show students how they can rearrange themselves and move around to also come up with their own fact families. I demonstrated a developing commitment to using multiple methods of assessment to engage learners in their growth, monitor learning progress, and inform my ongoing planning and instruction. I already showed the formal assessment from the first day, where students had to split their own families into a fact family and draw a picture and write the related facts. Here, on the second day, the students had to fill in a fact family triangle and write the related facts for story problems. As an extension, students who finished early could write their own related facts on the back. Here's one student who was confused how to write the related facts when you begin with a subtraction sentence. I also had informal assessment in the form of an activity where students each got a strip of paper with a related fact, and they had to find all their related facts in their particular fact family according to the paper they got, and they had to sit down as a team at the carpet once they were done. So this is how I informally assessed. I demonstrated a developing capacity to effectively design learning experiences using a variety of instructional strategies to encourage learners to make connections, build skills, and apply knowledge in meaningful ways. So I tried to use as many learning strategies as I could. We have music, I sang a song, students got to move around, rearrange themselves, and act out fact families. And we even had the fact family little art project where students got to visually represent their fact families. And then we had literature in the form of these little story problems.
Alright, so how did you guys put yourselves up? Short hair versus long hair.
Everybody's short hair. Where's the long hair?
Okay, so what's your first sentence? 2 plus 2 equals 4. So, what's your next sentence?
Because they're both they're four. And there's two.
So if we do 2 plus 2
There's
equals 4,
two short here. So there's two.
and then we switch them around and it's still 2 plus 2 equals 4, why is that?
Because there's four people at that. Because there's the same amount of long hair and they're double.
They're a double?
It's a tie.
Zoe just said the magic word. It's a double.
It's a tie.
So no matter what way you change them, they're both 2, right?
Wait,
They're both
that's
groups of 2. So it doesn't matter what order it's in, it's the same sentence. 2 plus 2 equals 4. Okay. And Blue Fat Family, what is your subtraction sentence?
4 minus 2 equals 2.
4 minus 2 equals 2. So 4 minus 2 long hair is 2 short hair. Only 3 numbers is what you need when you do a fat family. First you have to add and that equal a sum. If you learn that, then you're almost done. What fact do we have? Shannon, what fact do we have right now? 2. Hold them up there. Again. 2 plus 9 equals 11. Okay, let's rearrange for the next one. Alright, you can rearrange them any way you want. Take the sum from the back and move to the front. Then you can use those numbers to subtract. Same 3 numbers but a different fact. Great, they got it all by themselves. Someone who hasn't gone, tell me what fact they are. Kyla. What fact are they right now?
11
Mm-hmm.
minus.
Can you show her your card, Dennis? 11 what?
11 minus 2
Uh-huh.
equals 9.
11 minus 2 equals 9. Alright, so isn't that cool? Just by knowing 2 plus 9 equals 11, we know 11 minus 2 equals 9. Alright. Thank you guys. Stick them up there. Jose, can you give me another related fact? I demonstrated a developing capacity to orchestrate discourse and use effective questioning strategies to uncover, encourage, and extend students' mathematical ideas. On my lesson plan, I made a list of guiding questions from Dr. Bote's website to help me keep in mind what questions I should be asking. But you guys notice how these two are the same sentence and these two are the same sentence?
You said this is all.
Why is that?
Now what do we do? That's it.
But you know how up there you could switch the numbers and then it would be a different sentence?
We gotta write a picture.
How come you think they look the same here?